Thanks, everybody, for coming out to Data for Good this evening. We have quite an awesome speaker today. So really excited to get through to him or to have him come and share his wisdom and knowledge with us. By a raise of hands in the chat, how many people have been to a Data for Good before? Oh, we got a handful. Cool. Well, I'm going to take you through first a little bit of what Data for Good is. We're going to talk about some of the activities we have going on, and then ways that you can get, or I'll share some ways that you can get involved with Data for Good, and then we'll be on to our keynote speaker, Ryan Tessier. So Data for Good is a national organization, and we have chapters all across Canada in various cities. Each chapter is really associated with a city. And the purpose of our organization is to build data literacy in socially focused organizations. So, NGOs and community-based organizations, anybody who's really doing good for people, the environment, animals, things like that. The second part of Data for Good is about contributing positively to the data community here, specifically in Saskatchewan. And we do that in a few different ways. We have the Regina chapter is led by four co-leads. So myself, Scott Wells, who's on the call, Marina is not on a call, and Josh West. And together we I'll say run the chapter, but really Data for Good is about the community and about the organizations that we serve. So we really give a community voice to the direction of Data for Good, and we're just kind of the stewards of the community. We also have some amazing volunteers who help us run things. So we have Cody Rogers, who's our community lead, and he's the guy who's responsible for making sure these meetups get running and that the speakers have everything that they've requested in their riders, and make sure all the communication and presentations happen. So Cody, it's a lot of work, and so we appreciate that. We have new to our DataViz lead team, or a DataViz team, which is Arnav, and he's our DataViz lead, and so you'll learn a little bit more about that. And then we have Heidi, who's also new to the Data for Good team, and she's our communications lead. So she takes care of kind of a lot of the frontward facing communications. If you got an email from Data for Good recently, it came from Heidi. It really kind of takes a whole community to manage the community. The way we're broken down is that we have the chapter leads, we have the community lead, a DataViz lead, comms lead, and then underneath all of that, are all of our volunteers. And so altogether, the four activities that we really participate in are these meetups, light projects, major projects, and DataViz challenges. So a DataViz challenge is essentially an opportunity for over 60 to 90 days for a group of people to come get together and visualize a data set. Scott, do you want to talk a little bit about DataViz challenges and what they are?
Sure. Yeah, I think the intent is really to take a local-based data set and see if you can turn it into some sort of visual, tell a story, and really work on your DataViz skills, storytelling skills, and be able to present in front of a group. And so we do those on one of these monthly meetups, and folks can kind of walk through their presentation, and we have a number of judges from the data community that come out, and so they're kind of experts in their area or leaders in their areas, and kind of judge and provide feedback to everyone.
Yeah, it's a great opportunity for groups or individuals to take data sets and practice their DataViz skills. We have, when these come up, we have entrants of all types, juniors and seniors participate in these challenges. Next, we have these meetups. And if you don't know what a meetup is, you're participating in one. And meetups are where we bring in speakers to talk about data. And so it could be the United Way talking about how they use data to help with some of their programs. South Country has come in and talked about farming and data. 2-on-1 talks about how they've communicate, or how they've helped the community, and how they use some of their web data and phone call data to make better business decisions. And then we have projects, and we have a variety of projects. that we participate in. We have everything from the Regina Food Bank, which I know there's some project participants on here right now, but we've done things like help the food bank with some of their business questions and helping them organize their data to help give them more insight into their own business decision-making process. We've helped, again, 211 Saskatchewan build a bit more of a data infrastructure and help them use their web analytics to help them get insight into some of the ways they service people in Saskatchewan. So sometimes we work on projects that, where somebody's at the very beginning of their data journey. So maybe they've got, 8 years worth of data on one spreadsheet, on one tab of one spreadsheet. That's cool. Actually, I always forget this, but we actually had somebody whose data infrastructure was like a pile of papers. They had all their data in just loose leaf paper. So that's cool too. And then we work with organizations like the food bank that has a little bit more of a data infrastructure and is collecting things and has systems and has systems and tools to organize data. So we really work with any organization that needs help increasing capacity via data to help them fulfill on their mission. Scott, do you want to talk about our upcoming project?
Sure. So one of the projects that we have coming up is really to take a look at some of the data that's out there, whether publicly or through websites or otherwise, to understand the cost of living around the province. And so, as a lot of folks would probably realize, that through COVID and even before COVID, the cost of living was starting to rise, and we've seen inflation go up quite a bit recently. But one of the challenges that we've got across the province is it hits different communities quite a bit differently. And even though we've got things like Stats Canada data that there's going to be some new and refreshed data coming right away, some of it's already started to trickle through, it doesn't necessarily give the granularity that different communities need to see to understand what's going on from a cost of living perspective. And really, you've got a number of communities that have been hit a lot harder than others, whether it's through cost of living associated with food or with shelter or a number of other factors. And so this project is really aimed at how do we start to gather this information in a more frequent way and be able to drill down to different communities throughout the province to be able to show what's going on at different levels of the geography. And so this project, we're going to be pulling in a couple of individuals to help us scrape some information, help us actually package this together. And the really interesting part about this is there's actually a partnership with some of the organizations within Saskatchewan. So one being SaskTel, that has thrown out the option to provide some infrastructure. And so the hope would be to actually provide open data in some way, shape, or form. So whatever the work that we complete, other folks would be able to see the data and use the data as we go forward.
Cool. And are we looking for volunteers, or have we filled our roster?
So we've had some folks volunteer already. We're still open for probably a couple of more. This is going to be a project that probably is going to last somewhere between 3 and 6 months, depending on what's exactly going on. And so probably into kind of early summer, but we would have some spots still available if folks were interested in this, either from the mentor or mentee side of things. On all of our projects, we try and have some seasoned, experienced vets, as well as some newer folks that would like to learn.
And last question, Scott, is there any specific type of skill sets or experience that you're looking for on this project?
So a couple of skills that we're looking for, knowing that this data is going to be out on the web. So whether it is use or experience with APIs, connecting to them and working with that data, web scraping, being able to pull that together, or folks that are good with data management. So kind of prepping it and getting it fit for use for other folks. There will be other pieces related to visualizing the data and getting that prepped. And then there will also be a geospatial component out there. If any of the folks, when we've showed off the food bank visuals that were there, those are some pretty impressive GIS skills. And so there'd be something similar to that in this project as well.
Cool. Right on. All right, let's get to the main event here. We've got Mr. Tessier. Now, I think it's really important to note that we should be really grateful for Mr. Tessier. He's got 19 kids in his house. But what I thought about today, he just had twins that are 6 months old. And what a perfect environment to A/B test environments when you have twins. So that's probably maybe why I'm not a parent. Anyway, Ryan is also was previously from Sask Polytech, so you might recognize him from there. And he's indoctrinated all of his kids and maybe possibly his wife into Minecraft. So they are a Minecraft household, and as you can tell by all the games behind, they are a gaming household. So without further ado, I will end my talk in here. And Ryan, you're up.
All right, thank you so much, Kevin. I really appreciate it. And I just also want to give a shout out to the whole Data for Good Regina team, because you guys are awesome. I've been kind of semi-adjacently involved with you guys for the last, it's been like year and a half here in my time at Sask Polytech, and then my time now at Sask Energy. And I just have to say, you guys, I think when I advertised internally to Sask Energy, I called you guys, I called us the premier data organization in Regina, and that's absolutely true. The high quality of work here absolutely shows. And so Kevin, Marina, Scott, Josh, Cody, two others, can't remember the names, sorry guys. I just want to say thanks so much for putting in so much effort. And yeah, I'm really eager to speak, so thanks. Okay, I'm gonna share my screen here, and I'm gonna kind of talk a little bit about what the talk's gonna be. First, you're gonna get to know me, and I see a lot of faces I know, so some of you do know me. But for those of you who are also Microsoft certified trainers, some of these slides are gonna look somewhat familiar. But I'm gonna share my screen and we'll get started. So today, what I'm talking about is all about how we can make machine learning really, really easy with the cloud, okay? And I'll say a little bit more about what that means, but to me, it really means that, we're talking certainly from a data scientist's perspective. So a little bit of a disclaimer, actually a couple of disclaimers. One, I'm a Microsoft certified trainer, and I'll talk a little bit about that. So some of this stuff is going to be lean to the Azure side, because, when it comes to the cloud, you kind of have to pick a side to some degree, unless you're using some open source stuff. And then two, I've got a lot of things to cover here. So, and my background's in training. So if it does feel like a lecture, kind of sometimes par for the course with what we're trying to do here today. So my name is Ryan Tessier. I have a PhD in mathematics in quantum information theory, but I kind of got into machine learning through my master's. The PhD was a bit of a me thing. The machine learning was a bit of a, get a job thing. I have 10 years of teaching, leadership, labor relations experience, as well as data, technical training in post-secondary, professional development, specifically in primarily professional development and technical training. Located here in Regina, Saskatchewan, and I see some folks who are from Saskatoon that I know, so welcome to Regina, folks. Some highlights here, I screwed things up here, but we were running the Microsoft Canada Digital Skills Program through Sask Polytech for a while. So I'm a Microsoft certified trainer through that program. In that program, we taught data fundamentals, Azure fundamentals. I also taught Azure data scientist and Azure data engineer. Mix all that stuff together. The fact that I'm a manager of analytics at Sask Energy right now, plus my machine learning background, and we have some data science, I think. So if you want to get in touch with me as well, I have my LinkedIn page. You can always reach out to me there, and I'll certainly share some of this stuff after the fact, so you can get some of the links, because I do have some resources that I'm going to share. Okay, quick knowledge check, folks, and you can actually comment this in the chat because we still have lots of time, and I'll speed up if we run out of time. Oh, you know what? Kevin's got my poll, so go ahead and comment there. But if you want to say hi in the chat, that would also be really awesome. Maybe just say who you are and what your role is right now and interest in the talk. That's cool. Let's see, this is good. I'm watching the polls roll in. This is good. I'm seeing a lot of folks sitting. There's sort of a nice split of people. This is really good. This is really, really good. We've got about, yeah, this is like, it's like pretty perfectly balanced here. You'll see in a second. We'll just give you 20 more seconds and then post, and then we'll reveal the poll for everybody. 93% participated at this point. Okay, but you know what? We can close it. I think we've got almost everybody. So go ahead and close it. And then I think I can share the results here. So I'm going to, oh, is somebody sharing the results? Okay, I just want to make sure that the results are sharing to everybody. Can you all see them? Yeah, we're good. I see Cody nodding at me. So we're kind of evenly split, and that's really awesome because I planned for that. I'm trying to, this is going to be a bit of a Franken presentation because we're trying to meet all of the groups all at once. We have some people who are very new to machine learning and have some, to build some of the fundamental skills. We have some folks who already know the basics, and then a good majority, and then another group of people who are pretty experienced at applying the models. So I'm going to speak to each one of you. So if there's kind of a portion where it's not quite speaking to your needs, it's because I've tried to cram in everything for everybody. But yeah, go ahead and say hi also, if you don't mind. If you just want to kind of like say hi in the chat, feel free to, who you are, what your role is. I'll even get you started here. Thanks, Kevin. Just wait a few seconds here. We have Cody Rogers, production engineer at Dry Air. Hi, Cody. Nice to meet you again. Regan. The data for breakfast option didn't show up for you. Oh yeah, Jeremy, of course. Yeah, you'd eat data for breakfast. I can believe that one. Talia, hey. Farhad, postdoctoral fellow, Northern Crescent Inc., Calgary. Rachel, hi. Eli, good to see you. Joshua West, managing partner. Very nice. Keith Stack in Weyburn. I have a brother down in Weyburn, so I'm not sure if you're at McGill. Okay. Farzana, nice to see you. Martin, hi. Deepak, Claude, and master's student in physics, really cool. Arnav at Suncor. Hi, everybody. Welcome. Jane, project coordinator. Got Jeff Cow, new to data analysis. Excellent. Excellent. A little bit less on the data analysis here, a little bit more on the data science, pure machine learning side of things. Hi, Anessa. Nice to see you. Hi, Dhruv. Pauljan, analytics consultant. It's good stuff. I like that name. I like the analytics title. Well, that's good stuff. People always like to say data and analytics, but let's keep simple. Analytics. I like it. Okay, let's get going. So here's my talk in a nutshell. And I kind of had this tagline: production ML as easy as pivot tables. And so, like I said, let me just move some stuff here. So everybody gets a machine learning. We've got people who are new, people who know the basics, people who have a lot of experience. And what I'm going to try to do is have a little bit of something for everybody here. And one of the things that we're really going to get to here is how the cloud makes machine learning super easy. And the type of machine learning I'm talking about is not like the autocomplete on your phone or like key influencers. Sorry, Scott, I know you love that thing. It's really, how do you build a data model that works, that is going to get results for your business on a large scale? And that's what really amazed me when I got to looking at some of these, some of the services available on the cloud, because they're, as you're going to see, are machine learning services that make that production machine learning super easy. And as a data scientist, it makes your job much easier. Cuts the time in half, makes it easy to deploy, makes it easy to get results. Okay, so here's what the talk's going to look like. Part one, that's for our the folks that are sort of somewhat new. I'm going to talk about what machine learning is. I'm going to talk about what regression and classification are, because they're going to be relevant a little bit later when we get into the actual easy machine learning stuff. And then talk about the machine learning workflow, what it means to build a model, what it means to consume that model. Then we're going to do just a little brief primer on the cloud, because we need a couple things from cloud computing. And then in the end, I'm going to show you Azure Machine Learning Studio and show you some of the automated machine learning features that, like I said, let you build a model, deploy it to the cloud, and make predictions. And I'm going to show you why I was kind of blown away by it. Okay. And by the way, I could told you, because I'm a Microsoft certified trainer, this is the big disclaimer once again, it's going to be very Microsoft heavy because that's my bread and butter. But please don't let that fool you. I will talk a little bit about Amazon and Google as well, the Amazon cloud and the Google cloud as well, because they have similar products. It's the same sort of stuff. They're all competing in a competitive marketplace. So just because I'm talking about Azure, don't think that it applies just to Azure, okay? Okay, and warning, you will be looking at my computer screen and looking at me going through and check training models. This won't just be a PowerPoint presentation, okay? All right, so with that said, let's get started on learning about machine learning. So we're just going to start off with what it means to produce a predictive model and what machine learning is. And we're going to do it as simply as we can with sort of a visual that I hope you guys can kind of understand here. So let's start with sort of a scenario. Suppose a botanist collects some samples of flowers, okay? And you're seeing the little different kinds of flowers. Each sample has some features that might be measurements of the petals or the stems and other details. And the botanist can provide a label for those flowers. So for instance, you know, this like rose looking flower, they're going to measure, they do a measurement of the petal, they do a measurement of the leaf, they do a measurement of the stem. For the sort of the daisy looking thing, they measure the, what's that thing in the center called? I can't remember, but they also measure the petals, and they can kind of compare each of them. They can build a data set out of that and track what, you know, the basic information about these petals. Then what then happens is that because you've collected this data, you can also label these things based on what you know already. So for instance, you know that, you know, the certain flowers are, you know, like this one might be Bellis perennis, this one might be Rosa multiflora. You have labels that are attached to these flowers that are then tied to the measurements that you've collected on the flowers themselves. Okay, then where building a predictive model comes in is you might build that data, you build that data set and you pass it to a, why is this not working here? There's like, somehow I had some really nice, oh, there we go. Can you see that? Can you see my little visual there? Yeah, okay. So this is ideally the model. This is the algorithm. This is where the machine learning happens, right? So you take all those measurements and you take the labels that those flowers were given and you feed it into a machine learning algorithm. What that does is it spits out a model for you. And that model is used to make predictions, right? So then because the model has been trained on all these different flowers with labels, it's then learned how to, with some degree of accuracy, make a prediction when it receives new data. Okay, so like let's say there's another flower that pops up, you know, it looks like that daisy that we looked at before. The model itself will make a prediction. So in this case, it sees that it has the correct petal lengths, it has the correct stem distance, it has the correct, I can't remember, why can't I keep forgetting the center of a flower? I have no idea. Anybody can help me with that, I appreciate it. And then it does its best to classify that, and it does its best to make a prediction as to what that new flower measurement would be. Okay, well, what the label of that new flower would be. Okay. Okay, so that's the basics behind what a model is. Pistol. There we go. Thanks for Googling that for me. I appreciate it. So that's the basics behind how a model's trained. But as a data scientist, or like, let's say if you're a machine learning engineer or an analytics manager who might be doing data science off the side of their desk, what you care about is the workflow that's going to use this principle. And it's going to get you to something that you can use to derive business insights, right? Measuring flowers and making predictions on those, all well and good, but you know that there's more power in machine learning than that. So the first step would be you extract features. So, like when we were tracking when the botanist example, when we were measuring and building a data set of what are all the measurements of the flower, what's the pistil width, diameter, what's the petal length, what's the stem length, you build a data set off that, and then you process that data set to be you process it so that the model, the training, the algorithm can receive it. You make it nice for analysis by the machine learning algorithm. Then what happens is you split the data set. You split it into a set of training data, which is what you're going to train the model on, and then you hold some of that data back because you need data to make sure to validate the model. So once you train the model, you then have to validate that it's correct and that that it's making the predictions that it should. So just like in the previous picture, when we sent a new flower in, it's fine, all well and good that the model can say that it's Bellis florensis, but how will you know that it's correct or not? And I'm going to go through another example of regression and classification that is going to make this a little bit more tangible for folks who might be curious about that. So just like before, that training data is then fed into the algorithm, and you can see that's the little gears just like before. And that algorithm, which is really where the machine learning happens, trains the model, which is a mathematical model, makes a prediction, and it outputs a model that you can then, well, here's our little pixel for the model. You then validate. You validate whether the model is accurate or not. So you're going to take that validation data, the stuff that the model wasn't trained on, the data that the model hadn't seen yet, and then you're going to apply the model to that data set and make sure that it's predicting the way it should. Okay. Then if it's not accurate, what you do from there is you tune the model. So maybe you, and this is a word that's going to come up again, but you improve the featureization, which is the idea that you process the data set in a better way that makes your accuracy better, that makes it easier for the model to learn from that data set. Okay, so maybe that might be like, for the folks who know what we're talking about here, it might be, removing missing values. It might be making sure that you have the right scale of the numerical values, things like that. You might try a different algorithm to see if that works better, or you might tweak some of the parameters of the model, which get a fancy title called tweak hyperparameters, which are really the parameters that go into the algorithm that help make it more accurate. Okay. Okay, so what I'm going to do though, I want to make this a little bit more tangible. So what I'm hoping to do is go through this same process, but show you sort of what it looks like with some actual data. Okay. So maybe what we'll do in this particular example, start out with some historical data. And this is sort of one of these classical problems in machine learning about cycle rentals. Bicycle rental data. So there's like a data set out there that tracks the amount of cycle rentals that happen. And it sort of varies by whether it's a warm day or a cold day. And it really affects, and it kind of makes sense because, if it's a warmer day, people are going to bike more often. If it's a colder day, they don't really want to bike, right? So let's assume that you have this data set. On the one hand, you have the temperature in Celsius. And on the other hand, you have the amount of bikes that were rented that day. Okay. What we usually call the data that we're feeding into the model, the metrics that we care about that we're going to use to train the model to make a prediction with, we call that a feature. And a label is the thing we're trying to predict. So in this case, our feature it's just a simple single variable problem. Our feature is really the temperature, and the label is the thing we're trying to predict. So we're trying to predict the number of bikes that are going to be rented on a given day based on the temperature. Okay. Just gonna click that. Oh, I'm going to back that up a second here. Okay, so now this is a nice little picture here. So here's where that first step comes in. So this is the data set, and we're going to assume everything's really nice about it. In most machine learning, this is not the case. So there's usually some work you have to do to make the data set nice, but in this case, it's a really nice data set. We've got temperature over here. We've got, you know, the daily bike rentals over here. Then what then happens, and remember I talked about the splitting of our data, right? Where we isolate a certain amount of the raw data that is going to be used for training. And then we take a subset of that, and that's our validation set. That's the set that we're going to be predicting. Or that's the set that we're going to be comparing the model on. So we're going to take this set of data to train the model, and then we're going to take this other set of data to put back into the model after we've trained it to make sure that it's accurate. Because, you know, what's the use of having a model that only predicts accurate values on data it's already seen before? We want to be able to give it data that it hasn't seen, right? Now, in this case, because both of our variables are numeric, they're both continuous, this is the example of a regression problem, right? Where we need to find a line of best fit on a set of points. And if we find that line of best fit, we can then, based on whatever temperature it is, we can have a reasonably good prediction of how many bikes are going to be rented on a given day, or on a given day, again, for a given temperature. Okay. So what then happens is that data, that training data, is fed into the model, and the model produces a line, and then that essentially is a mathematical model. So for instance, I'm just going to zoom ahead a little bit here, and you can kind of skip all the gory mathematical details here, but the line that's trained is, you know, it has an intercept of say 35, and it has a certain slope. So what the algorithm is doing is it's producing a function like this, right? Is that it's using machine learning to iteratively produce a mathematical function. Okay, I'm kind of hiding the algorithmic details a little bit, and there's a number of algorithms that end up producing these models. But what's important for our purposes is that, you know, this training data goes in, a learning algorithm is applied, and then it builds the parameters of this mathematical function that let us plot a line, right? And then that line can then be used to make predictions, right? And then it gets applied to the validation set to see how accurate it actually is, right? So the validation set is then fed in, and you make a set of predictions. So over here, I'm just trying to move some things around here. Over here, you've got the values that the newly trained model is predicting, and the values that are the true values in the validation set, right? So we took the original data set, which was actual data that was collected. We split it up into two parts. One was the training set, which was then the algorithm looked at and built the mathematical function, and split it up into a validation set. The validation set is then, you know, hidden from the model because it wasn't trained on that data, and it's used to validate how correct our model actually is. So our model predicts these values. So for 54, our model's predicting, so for 54 degrees Celsius, our model's predicting 116 bike rentals on that day. The actual data set said 114. For 62 degrees Celsius, our model predicts 128 bike rentals. 129 was the actual value. So you can kind of go through this and do that comparison, but we didn't do too bad, right? We've got a pretty accurate model. And Deepak's asking the question, a good question, is how is this different from forecasting, or is it the same concept? Yeah, it is very similar to forecasting. Like it's not, you are building a model that's going to forecast future events, or going to be able to, it's going to be able to make predictions for you. The real difference is in how that model is constructed, right? That model is constructed by giving this data to a learning algorithm, and instead of having to do a bunch of statistical calculations, you can, it'll just spit out a mathematical model for you And then there's some ways you can kind of track and understand what's, how good of a fit it was, okay? And there's another question from Jeff saying, so there's an unsupervised learning as well. So this is an example of supervised learning because the model, when we trained it, knew what the actual label was. There is an example of unsupervised learning that I'm going to talk a little bit about as well. I'm not going to go into the detail. All I need is regression and classification. So that's what I'm sort of showing you right now, because that's what works the best with automated machine learning, which we're going to get to, okay? These are the things so it might seem like I'm kind of off topic a little bit here. And those of you who know what's going on with machine learning, you're like, okay, well, yeah, this is basic stuff. But this is what you need to understand and appreciate the value of what automated machine learning really brings, okay? So that's kind of why we're talking about this. So the next thing I'm going to talk a little bit about, again, for the folks who I think are fairly new to this is the other form of supervised learning, one of the other forms of supervised learning. The reason what I'm introducing you to here is regression, which is predicting continuous values, values that are like, the number of bikes that could be rented on a certain day. It's making forecasts, like Deepak commented. But classification is the other sort of most common form of machine learning in its application. And in this case, what you're trying to do, your features in this example, what we'll kind of pretend here is the features are diagnostics about patients. Okay, so in this case, let's say we have a data set that is a bunch of different diagnostic information about patients at a health clinic. Their body mass index, their cholesterol, what's another one? Maybe their junk food, how much junk food they eat. And these end up being the features in this classification problem. And you want to know whether that person's going to get diabetes or not. This is a fairly classical problem in classification. So over here, we have all these diagnostics, okay? And these are just sample numbers because, it's health data, I want to be sensitive about it, but there are some good health data sets to make this, to practice this with. And then Y is whether they're diabetic or not. So for instance, so in this case, hey, quick question for those of you who are fairly new. What do you think 0 means? Is it diabetic or not? It's an easy question. I want to see anybody who knows a lot about computer science answering this one. Not diabetic, thank you. Yes, exactly. And so that's the idea behind classification, right? We saw regression, which is forecasting, continuous values or, numbers, and classification, which is forecasting labels, right? So in this case, 0 means not diabetic and 1 means diabetic, okay? So as before, you follow the same process. And again, the important thing I'm trying to emphasize here is the process that we're following, okay? And it does seem a bit onerous, but that's kind of by design a little bit because I'm going to show you how easy things are with automated machine learning. Okay, so once again, features over here, labels over here. We take our training data set, which we're going to show to the algorithm, and we hold back that validation set, right? Again, the reason this is supervised learning is because the data sets that we're using to train the model on are labeled, and the data set that we're holding back also is labeled. Eventually, you want to be able to predict on new data that is not contained with any of this data, but the validation set is how you show that it's a good model because it predicts on data that it's never seen before. Okay. So this is a little bit complex in its way, but when it comes to classification, the gist of this is you sort of use a little bit more complicated function that the algorithm spits out. It's we don't need to get into what it is, but it's sort of this function that goes from 0 up to 1 at the top. And I'm just going to grab a pointer here, just because there should be a 1 there. And what happens is it then predicts a probability. Okay, so when it comes to classification, there is math behind the scenes, even though you're predicting something that's just a label, whether they're diabetic or not. But what the model that you're training is actually predicting with classification is a probability of whether the individual data point is, or with it's like a certainty. It's a probability of how certain the model is that that particular data point is going to be diabetic or not. So let me just make sure everything's popping up properly on my. So for instance, right here, you train the model, and we're not showing the mathematical function by design because it's somewhat complicated, but this is a mathematical function that makes a prediction. And so at each diagnostic, so for instance, like for this patient who, you know, eats 3 bags of chips a day, eats, you know, has really high cholesterol, eats lots of lettuce or something like that, or whatever it is, whatever you're trying to track, it makes a prediction that there's a 20% chance that this person's diabetic, 80% chance that they're not diabetic. For another person who might have, say, a lot, you know, they do have that high cholesterol, they do eat a lot of chips, it's predicting that they are more likely to be diabetic and less likely to not be diabetic. And then the classification algorithm, then the model just sort of makes a cutoff point. And usually this is 50%. So usually the way that a classification model works is that if the model predicts that it's more than 50% chance that the person's going to be diabetic, it's going to say, it's going to classify that as a 1. And you see that's what's happening here. And if it's less than 50% chance that that person's going to be diabetic, it's going to classify that as a 0. And so your model ends up spitting out the same labels that were going into it, even though it's actually it's like a probability. It makes probabilities, okay? And then the way that it's sort of assessed is based on and I'm just going to kind of skip through this here. We care a lot about the accuracy, but typically when you're doing data science, you sort of go through an entire data set and you try to see how many times did it predict properly? How many times, you know, how many times did it predict that somebody was diabetic versus when they were actually diabetic? How many times did it predict they were diabetic when they weren't diabetic? How many times did it predict that they weren't diabetic when they were diabetic? And how many times did it predict that they just weren't diabetic when they weren't diabetic? So this is what's called a confusion matrix. I know this is a lot of extra terminology if this stuff's still pretty new. This is just a way that we sort of, you know, when you're doing data science and machine learning, a way that you assess whether classification was accurate or not, because you want to make sure that you have as many possible values that are actually diabetic as were predicted to be diabetic, or weren't diabetic when they were not supposed to be diabetic. Most of the time, at least for our purposes, we're going to focus on what's called accuracy, which is really just how well did it predict whether somebody was diabetic or not. And you can kind of think about it that way. Again, sorry to the machine learning specialists in the audience. Nobody said they ate data for breakfast. But most of you, I think, hope you understand I'm sort of doing this a little bit more generally. Okay, so that's regression and classification in a nutshell. We got into the weeds right away. So that's great because I'm going to pull us back out. The important point to know about this is that what we're doing here is that we're feeding data in, training data in to train a model. We're holding back a certain amount of it to assess whether that model was accurate or not. And then that's kind of that sort of gives us this idea of how good our model was and how well our algorithm trained the model. Okay. And Claude, good question. I see you know this stuff. So you're asking, do we need to normalize the value of each feature? You do, and that's a good question. When I talked about featureization, that is something that needs to happen in most machine learning models, and most machine learning algorithms to make them accurate. But I'm not going to get into that because I'm just trying to do this fairly generally so that we're kind of serving both audiences. Okay. But that is definitely something that needs to happen. There's other types of machine learning algorithms available. There's time series for making predictions on data that moves over time. This, by the way, if you get into machine learning, nobody says this one's super important, but this one's like extremely important because most businesses care about making predictions for the next day or the next day or the next day. So just a pro tip for those of you who are in machine learning or data science, brush up on your time series skills, because we care a lot about those as a data scientist. Clustering, and somebody asked, what if there's unsupervised learning? Clustering is another important piece, and it's used for a different purpose. So like regression was for predicting, continuous values. Classification was for predicting labels. Clustering is when you sort of have a bunch of data points and you want an algorithm to identify clusters. And I know, Kevin, you worked in marketing, so you care a lot about clustering algorithms. I don't know if you've ever used one, but making market profiles, this is a really common use of clustering. There's a reason I'm not getting into this stuff, by the way. It's because it's not in automated machine learning, and we're not going to talk as much about it. I think I gave you guys sort of the gist of that stuff. It only gets easier from here, I promise you. And then lastly, I sort of talk about neural networks. There's a lot of different stuff you can talk about in machine learning. There's all kinds of fancy AI stuff. But what you learned here today is the very basics. All of the stuff that has come from machine learning, all of like cool vision and self-driving cars, all started, and the theory itself started with regression and classification, the two most basic forms of supervised learning. So those are the ones you're going to hear the most about, and those are the ones we're going to look at today, okay? And you're going to see me do an example of it in automated machine learning. Okay, so one last step to this machine learning workflow. We talked a little bit about it. We extract our features, which is, by the way, also called featureization. When we say featureization, this is sort of how we build a good data set to feed into the model. We split the data set into our training and validation. We train our model. We then validate to make sure it's accurate. And then there's one last step that's actually one of the most important steps that they don't talk about enough, I don't think, which is deployment. And that's one of the things we really care about, because once you've trained the model, you want to be able to use it. So most often, what deployment ends up being is you have to take the model, package it together with everything you need from a programmatic perspective, everything you need to run it, and you put the model on some computer, y equals mx plus b, and then people feed it data. So if you're a business, you might feed, or if you're the regression, you might feed in 59 degrees Celsius, and then it's going to spit out how many bike rentals there will be, 119 or something like that. Okay, and then you want to be able to do that every single day, because that's what makes machine learning useful, is that you have some computing power that lets you make predictions every day with new data. Okay. But there's some challenges. All of this stuff has challenges, especially that deployment part. Takes a lot of skills, right? Nobody said they eat data for breakfast, right? I don't eat data for breakfast, by the way. I am not that good. But and that's true. It requires a lot of skill to do machine learning. You often don't have enough computing power to do it. It takes like 24 hours. Some models take like days upon days to train, if you want to have a good and accurate model. Finding the right model requires lots of experimentation. You have to try and try and try again and make multiple models, and you better make sure you're tracking them well. Models also require lots of fine tuning. So when I was talking about featureization and tuning hyperparameters and picking different algorithms, you have to tweak that all to find an accurate algorithm. And they require lots of tracking to make sure you find the best one. Okay. But this is where I get excited. And this is why I really wanted to talk about this topic, because I wanted to show you how almost like all of these challenges get you can mitigate so many of these challenges with some of the cool cloud machine learning features that are available on, Amazon, Google, Azure. Okay. So that's why we're going to take a little detour in 1 second, but we've got a quick recap. Okay. Oh, what? I think I put this in the wrong spot. Let's see which one we got here. I put my phone in the wrong spot. I apologize. Which one are we asking here? 2 is, yes, here we go. I'm going to launch a poll to see if you picked up a little bit about what I was talking about. Okay, so we want to use machine learning with car sales data to train a machine learning model that predicts the price of a car based on its make, its model, its engine size, and mileage. So what task would you choose? So again, think about, what are we trying to predict? Are we trying to predict a label? Are we trying to predict a number? or are we trying to predict based on the date? Okay. Oh, that's my best Jeopardy. Sorry, folks. Okay, well, 5 seconds. Okay, I'm going to share results. So regression had 83% and classification had 17% of people. Would somebody from classification happen to want to say what they, why they picked classification? Don't worry, I'm putting you on the spot. Somebody said multiple regression. Ooh, Keith, you must eat data for breakfast. That sounds tough. No, multiple regression could happen for sure, but we're keeping this one simple, okay? That's okay. The correct answer here is regression, because we're trying to predict price of a car. You know, if we were trying to predict, say, whether a car was going to get into an accident or not, based on, you know, the driving history of its driver, that would be classification. Regression here, we're trying to predict the actual a number, right? So anyway, no worries. Well done, everybody. Thank you so much. Okay. All right, so here's my little detour into the cloud. So let's talk about what cloud computing is. And then we're going to talk, I'm going to try to wrap this back around in a bit and talk about why this helps solve some of these problems. So cloud computing is the on-demand delivery of computing services over the internet. And it enables faster innovation because you can get the resources whenever you need them. Flexibility, because you can get exactly the resources you need. So, you know, unlike in a current, say, IT department, you don't have to just live with what the servers that you've got. You can get all kinds of servers optimized for all kinds of stuff, and economies of scale, because it's a large cloud service provider and it can really help cut down a lot of your costs. The standard things that you, like the traditional things that you get from a cloud computing provider are things like compute. And this is sort of like a specialized term used in cloud computing to mean something that does something in the cloud. So like a virtual machine, you know, like a virtual computer in the cloud could be something, or, you know, just if you know what a container is, that is kind of holds a program to run it on the cloud. Networking, everything that you run on the cloud is networked together to talk to each other. And we'll see it. We don't do too much of that here, but that's something you can do. Thanks so much. Take care. I see somebody's taking off. Storage, so things that you can store on the cloud as well. So like, you know, you can put information on the cloud. And actually, this is where people's first exposure to the cloud came in a lot of cases, like Dropbox, right? Dropbox was probably hosted in the cloud years ago. And then just, you know, the rest of the cloud became more popular, but cloud storage has been a thing for a long time. And the part we care about, analytics, okay? Now, there's top 3 cloud computing services. This is just some general knowledge to know. Amazon Web Services, that's number 1. Microsoft Azure, number 2. And Google Cloud is kind of number 3. Amazon Web Services, well, actually here I have a little picture for this. Amazon really does lead the market right now. So they're sort of sitting at 33% of the market, with Azure trailing at 21%, Google Cloud at 10%, and then there's a whole host of other cloud providers that you can go with. Like I said, I know Azure, so when we get into the actual cloud part of this, we're going to talk about Azure. Okay. Okay, the one thing I just want to talk a little bit about here is infrastructure as a service versus platform as a service versus software as a service. A lot of people know what software as a service is. And the reason I'm doing this for a reason is because we're going to interact with platform as a service today. Software as a service is things like Netflix. You pay for a subscription, and you get it through the cloud. You go into your web browser and you can access it. Pay a subscription fee, you're good. The classical cloud model was what's called infrastructure as a service. Okay, and this is like, you have a virtual machine that can host stuff for you on the cloud. So like, you remember the server rooms that most businesses have? Well, the cloud provider just gives you basically a server computer that's virtualized in the cloud for you. This is how Amazon kind of got there first. They were doing this years ago. And this is a good majority of Amazon's business is infrastructure as a service, where they're just giving out virtual machines. And that's kind of how they built the backbone of their service. But the more modern cloud providers are really leaning towards this idea of a platform as a service. Adobe, you know what? There's a comment in the chat saying Adobe is a good example. Yeah, Adobe is a fantastic example of software as a service, for sure. As long as it's through the internet, through your, public internet, and it's kind of hosted and available to you at any time, and you pay a subscription fee, that's software as a service. Platform as a service is sort of the newest model of all of them. And platform as a service is increasingly becoming the standard. And it's what Azure really has done. And it's kind of how Azure's made Microsoft's made its sort of name in the market, is that they have a lot of platform as a service offerings. It's kind of their it's where they've tried to focus. Now, Amazon, all of them are offering all the exact same services. It's not like one's better than the other necessarily. They've all kind of got competing products at this point. But platform as a service being these self-contained little things in the cloud that you can get without having to get a whole server computer in the cloud. If you want a database, you just click on the database icon in Microsoft Azure. Let me just show you quickly what I mean by that. So I'm just going to move my Azure account over so that you can see this. Right? If I were to get a database, I could just go to the little box over here and say, I want a database, and there's my database. I can get my database right there without having to set up a server computer or anything in the cloud. Or I want a lot of this stuff is pretty arcane, a virtual network to network stuff together. I just click on the virtual network. Or I want some storage, so I just click on storage. They're sort of self-contained little chunks of the cloud that you don't have to think about the virtual computer itself. You just have to set it up and do something on it, okay? So I always think about this as, I'm just going to share this analogy with you, and then I'm going to jump to the next part, because I always think about it this way, okay? It's like how you make a cake. Software as a service is like you buy the birthday cake, right? You just you go and you just buy it and it works, and there you go. Infrastructure as a service is like you rent a house to get the kitchen, or maybe 2 kitchens. You want to bake a cake, so you pick one of the kitchens in the house, right? That's like the server computer. And once you load all the programs on it, then you can build something. Platform as a service is you rent a professional kitchen. You just go into the kitchen and you rent it, and you can now you have all the tools you need, and you just make your cake, right? So it's all about what you're trying to do with it. And infrastructure as a service, you have to rent the whole computer with an operating system and the server computer and everything like that. With the platform as a service, you just get what you need. If you want a database, you get a database, okay? You don't have to worry about connections or anything like that. It maintains everything for you. Same with the professional kitchen. Somebody cleans up everything for you. This is sort of a picture that you can this is one of the classical ways that they break things up in the cloud. And don't focus too much on it. It's a bit of extra detail, but it just describes the division of responsibilities on the cloud. But the reason I cared about platform as a service is because what I wanted to show you today is platform as a service. So that's at least something you should know about the cloud. That's your one takeaway from it. We're going to be using Azure Machine Learning today because I'm going to show you how easy it is to train models on Azure Machine Learning, and how it makes life so easy for everybody. And again, I also want to say Amazon SageMaker does the same stuff. Google Vertex AI does the same stuff. My background's in, as I've said, Microsoft, so that's what I know. Okay. Quick question for everybody. See how we're paying attention. Number 3. So which of the following requires the most user management of cloud services? So let's just think, right? Think about house analogy. Which one would require the most? Just wait. It's here. Don't worry, we're doing pretty good here. I've got about 15 more minutes of stuff to show you all, and then we'll wrap it up, okay? Okay. I am going to end. Oh, no, we'll wait till we have at least 85. posted. Okay. I can end the poll and I'm going to share with everybody. All right, so infrastructure as service, that is the correct answer. The other ones, very good guesses, everybody. Appreciate it. The reason infrastructure as a service really requires the most management is because you're renting a whole virtual computer in the cloud that you have to load everything on. So if you ever want to get to the point where you build your own software as a service, you're going to have to load all the stuff you need, like your Python and your runtimes, and you got to get your Visual Studio on there, and you got to configure all your tools. Platform as a service requires less management because it just basically, you say, I want something to build something on top of. I want a platform that's going to let me do machine learning models. What's Azure Studio? And then software as a service, obviously you don't have to maintain Netflix. You just log in and you access Netflix and you watch your show and you're happy. Okay. All right, now this is the part I'm really excited for. So this was the tagline. I said this is going to be as easy as pivot tables. So let's remember what pivot tables are here, everybody, just in case you forgot. I am actually fuzzy on pivot tables. That's a dirty secret. Good thing my director's in the chat today. I'm not great with pivot tables, I will say. Oh, but so with the idea with a pivot table, though, is that it's sort of a way of summarizing data, right? Is that you have a big, large tabular data, and you can do a few clicks. And I think my visualization froze. A few clicks, and it will let you summarize all the data that's available. You'll notice, again, you can obviously tell it's in Excel. So most of you probably know what this stuff is. So it's going to summarize the information as you need it. It just takes a couple of clicks. But what I hope to show you today is that you can train production level at machine learning with these services just as easy as a pivot table. Okay. So what's Azure Machine Learning? So this is a cloud-based platform for machine learning. There's that platform as a service we talked about. It sits within an Azure subscription, and you get an Azure workspace. So just like you say to the cloud, I want a database, you say, I want to train machine learning models. So in my case, like I was going to show you here, I could just type in machine learning, and I'd have the ability to access Azure Machine Learning. Okay. And you'll notice I already have one set up right here. This is the resource that we're going to be working on in a second, and where I'm going to show you all the stuff. So what this service provides, though, is it's not just it doesn't just provide the automated machine learning that I'm going to talk about. It also gives you the computing power you need to train your model. It gives you the ability to track your data. It lets you track all the experiments. So remember when I talked about how tracking was really hard? It does that for you. It catalogs your models. So when you train a good model and you have all the metrics associated with it, you don't have to, write it down on a piece of paper. It's all tracked within Azure Machine Learning, and or log it in Excel. And then it's got a number of other services available to it as well to make life as easy as it can be. So some features that it has, it gives you automated machine learning with the UI. And so this is what we're going to focus on in just a second. But it's also got this cool graphic interface that helps you design machine learning pipelines so that you can really track how you have processed the data set and formatted things. It's got the Jupyter notebooks, which if you don't know what that is, they're like the most common way that you run code for a machine learning scientist or a data scientist. It lets you manage and label your data sets so you don't lose your data sets, you know what's happening to them, you're being tracked. And then again, it tracks your experiments, the runs of your experiments. So as you're trying to train different experiments and need to try different runs and try different things, it tracks all of that. And then it also tracks the models that you've trained. Okay. So I'm going to jump into Azure Machine Learning to kind of show you around quickly. And then we're going to get into the part that I love. Okay. So I'm just going to show you how I get there. Again, this is Azure. So just so you know, Azure has a nice friendly interface. So if you ever need to get on, there's also, I should mention, because, you know, this is fairly practical what we're doing here. If you're going to watch the YouTube video later, you can come back to this and just sort of play around a bit. There's actually a couple different ways you can get onto Microsoft Azure, and I'm just going to post them into the chat. There is a free account available if you haven't used it before. And there's also, if you are a student at a post-secondary, you can get $100 free of Azure credit to play with. Everything on Azure costs a little bit of money. You know, the more computing power you use, the more money it costs. But with the free account, you get $200 of credit. And with the student account, you get $100 of credit if you're a post-secondary student and signed up with a post-secondary email address. I know this stuff fairly well because, again, I've taught it. All this stuff is available for Amazon. In fact, I think the Amazon stuff is a little bit better, to be honest with you. And Google Cloud also gives you some free accounts as well. So definitely check out their stuff as well. But I'm going to post those in the chat, and I'll remind you of them in a moment. But again, if you're in Azure, it's easy to get into the studio. You click on your platform as a service, Machine Learning Studio. And literally, it's as hard as clicking Launch Studio to bring you into this screen right here, which is the landing page of Azure Machine Learning Studio. So this is where you sort of end up. And you'll notice here I've pre-populated this, my training account, with a number of different models that I've tried out. You know, you have, just to kind of show you the navigation here, you can access those Jupyter notebooks I told you about. So if you're one of the experienced data scientists, this is where you can do a lot of your more advanced work. I'm going to skip this one because it's the one I love. You can get into the designer, which is really neat because you can build these automated machine learning pipelines. Just so you know, I just want to show you, some folks here probably love flowcharts. It's so nice. You can just design a complex machine learning algorithm and deploy it with just this nice visual drag and drop interface. Then there's the tracking features. So, you know, it tracks your data sets for you. You'll see that I loaded some data in here ahead of time. And I'll talk about where I got the data from in a moment. It tracks the different experiments you've run. So the number of, you know, the different models you've tried to train. And, you know, it gives them these sort of, if you click into one of them, it gives you these sort of like list of all the different runs. And they always give them these fancy names when they generate them automatically. In this case, it's salmon cheetah, khaki book. If you go into a different experiment, you know, like this one right here, they give you things like helpful key, dreamy dolphin, and it really tracks all these important metrics. Again, some of this is going to look a bit Greek if you don't have a lot of experience with machine learning. But for those of you who do practice this every day, you're seeing, you know, there's metrics that test how accurate they are. It tells you how long it took for those models to train. And you'll notice some of these are like 1 hour long of training duration. Some of them are 11 minutes. They take a while. The different pipelines you've built with that pipeline designer, the different models that you've actually deployed upon the world. So we talked about deployment a little bit, and then various endpoints. If you know what a REST endpoint is, it talks about the various REST endpoints you have in the cloud, which let you activate and use that model by sending data into it. Okay, there's a bunch of other stuff here. It's a little off topic from where we want to go, but this is the idea behind Azure Machine Learning. I'm just going to hop back to my slides for a second. Where are my slides? Okay. But what I care about and what really wowed me about some of these features is this automated machine learning feature. So again, it takes a lot of the hard work out of machine learning. All you do is supply data in. It does all the work for you. It selects the algorithms. It picks from a bunch of different algorithms. It tries a bunch of different ways of processing your data. It tweaks a bunch of the parameters on the algorithm, and then it just spits out a model that you can use. When I tried this, I was kind of blown away because, and there's just a question, I just saw a question pop up saying, on what basis is the accuracy of the model calculated? Are there predefined definitions? Absolutely. And I'm going to show you that in just a moment, okay? So just here's the usual way, just so if those of you who don't know what's going on, I want you to get a visual of the usual way that we train models. We do code. We write these, we use various machine learning packages. We use them in Python or R, and we run this code to build a model that is hopefully accurate, and we test them out. So this is the traditional way of doing it, and it takes a long time. It requires a lot of manual effort. You'll notice I do use MLflow, so I'm used to tracking, but it's not always obvious that you're going to track with MLflow. And sometimes when you start data science, you don't know how to track this information. But anyway, this is the way you do it. It's complicated. That's the gist of it. But with automated machine learning, it's a really nice way to just kind of get yourself off the ground. And I'll talk about the advantages. But now I really want to actually show you how we do it. Okay. So I'm going to jump out of my slides for a second, and I'm going to show you. So to start this off, and just to kick off what I've done, what I'm going to show you today, Kaggle.com, I'm going to link to this in a bit, is this data science website. If if you're one of the new folks in the crowd and you want to sound like you know a little bit about data science, just talk about Kaggle.com and about the data sets you got off Kaggle, because you'll sound very hip. This is like this public store of a bunch of free data sets. One of the classic, and then what it does is that it has these competitions where companies can submit problems to Kaggle and have teams of data scientists work on those problems to make a model that predicts things accurately. Yeah, right, exactly. And probably the first most easy problem with the nicest data set is this Titanic prediction data set. So the idea is that on Kaggle, there's a very common problem called the Titanic disaster survival problem. You can read it right here. The data set is it's a list of passengers from the Titanic, and you want to train a model to predict whether they survived or not. Quick question for everybody: is that classification or regression? I want to see one of those folks who answered they're new. Is it regression? We're trying to predict if they survived or not. I'm seeing classification. Classification. Yes, absolutely. Thank you, Kevin. Yes, indeed. Thank you. So it is classification. So I'm going to just skip you actually downloading it. You can go on here and download it yourself. I'm just going to go to my desktop and open up this data set. So I just want to show you what it looks like. So we're going to be training a model here. I don't know if we'll have time to finish it up, but I do have some models trained already. And so you'll see there's passengers. They have whether they survived or not. They have a bunch of different information, like their sex, their age. Can't remember exactly what that is. Parts, the ticket, and there's some metadata on Kaggle that tells you what these are as well. So you see it tells you what each of these represents because in a data dictionary. So now we're going to start training a model right here, right now, just like we do a pivot table. And this is in this wonderful automated machine learning thing. And you'll see I've been using it a lot because I've been preparing for this session, but we're going to try one out. So new automated machine learning run. We're going to try to train that. We're going to try to train a model to try to predict whether somebody is going to survive the Titanic or not. And one thing I've already done ahead of time is bring in the training data set. Okay. Now, this training data set is going to get split up into training and validation data by machine learning itself. This test data set is for the competition itself. So one thing what I'm going to show you is that I actually ended up training a model automatically and submitting it back to the Kaggle competition just to see how well it did. And we'll go into that. I don't want to spoil it just yet. So you pick your data set. If there's not one that's already there, you can create one right here. You pick your data set, you hit text. You pick, what experiment is it going to go under? Is it going to be one of the experiments I've done already where we're going to track it, or are we going to create a new one? We're going to call this one classroom experiment. Classroom experiment, Titanic. Okay. You pick the column you want to predict. So remember we looked over the data set. There's passenger ID, whether they survived or not, their name, their sex. You pick survived because that's what you want. You pick the computing power you want. I'm just going to pick compute instance. Again, there's stuff you can get into to learn more about this. I'm just going to pick, this is the computer that's going to do the actual work for me. And remember, this is why I focused on classification, regression, and time series forecasting. While this is powerful, it only works for a small subset. So again, those of you who are professional data scientists, don't worry, you're not going to lose your job. So let's do we're going to do classification. If you enable deep learning, you can, it'll be more accurate, but it will take like 24 hours or more. So let's just hold off on doing that. I'm going to do I'm just going to do one thing because I want this to actually finish before the end of our time. I'm just going to make this 0.6. So remember when we talked about what is the metric? How do you pick the metric? What I did here, sorry, no, I'm just going to cancel. I just want to show you where I clicked in case you didn't see that. There's additional configuration settings. So those of you who know what you're doing, you can click this and you can pick the metric that you care about. I'm going to pick accuracy because that's sort of the easiest one to understand. We can add an explainability to explain which features are the most important ones for the prediction. You can block a bunch of models. I'm going to block everything other than logistic regression. Don't worry about all these fancy names. Don't let them scare you or anything like that. I know that when I looked at these, like I know machine learning and I was like, holy man, what the heck's an extreme random tree? You know, that sounds intense. So, you know, it's not something that, you know, some of these are just like, there's a lot of different models out there and you can't, unless you've done this for a long time, you can't know every single one. But I'm only going to this is basically, I'm blocking all these. I'm saying that, so the automated machine learning is going to, if I didn't do this, it would try all these algorithms on a different run. So I'm just trying to limit things so that we actually finish within the time period we have. And I know we're almost over here. And I'm just going to set a metric score criteria. Don't worry about what I just did there. If you're new and don't know what you're doing, you don't need to configure any of that your first time trying this. So you just pick classification. Now, remember we talked about the validation type? There's a few different ways to find that validation set that we talked about. So I'm not gonna go into that, but we're just gonna let it pick it automatically. If you want to give it a data set to test itself out on, that it has never seen before, that has no labels, you can, but it's a preview feature. So it's going to be a little bit awkward, and it really is. One thing with the cloud is that everything's changing all the time. So there's lots of new features that come into existence and out of existence fairly regularly. So this is a new feature that I've even seen since I was doing more of this, you know, like I don't think I've clicked on automated machine learning for a while. And I was like, oh, test data set, that's nice. So let's click finish. And just like that. Oh, thanks for sharing that, by the way. I'm gonna post that as well. I'm just gonna highlight that. Paul Jin shared that Data Robot is one of the pioneers in this automated machine learning field. Yes, that's a very good shout out to Data Robot. I hadn't heard about them, but you know, if there are a lot of services that do automated machine learning. This isn't the only one. It's just, this is one of the things that's useful about this is that because it's also on the cloud, you get the computing power that you need as well, so that these things actually finish. And you'll see it setting up the run and everything like that, okay? In the interest of time, we'll see if this thing finishes. Sometimes they take a few minutes, okay? But I'm gonna show you what I ended up doing, okay? So I ended up, when I saw this and I said, hey, we're gonna talk about automated machine learning, I wanna show how good this thing is. So I figured, why don't I just train a model and then submit it to, then use the data set that Kaggle gives me, make a prediction, and submit it back to Kaggle itself and see if I can get a score on the leaderboard, see how I do. So what they'll often do in Kaggle is they'll have the training data set, which is what you're supposed to use to train the model. And then they'll have a test data set that doesn't have any features that you're interested in. So I just opened up the test data set and you'll notice that there is no survived column on this. This is how you compete in the Kaggle competition, is that they give you the data set without the thing you're trying to predict and see how well the model performs on that. So what I did was I trained a model and I deployed it. So the thing is that after you train the model, you then can deploy it into the cloud. So I currently have this ML Made Easy Titanic model that I've deployed into the cloud. It was one of the models that I trained. And then what I did was I sent some data in. And notice I can actually send some data into it right now if you're interested. Which I hope. See, so right now I can there's even a feature to just test it out. I hit test and it just made a prediction for me right now. But I took this and I applied it to the entire data set here. And then I submitted it back to Kaggle to see if I could get on the leaderboard. And where am I here? Titanic, Kaggle. So let's see my submission. So check it out. Here's where I am. I'm jumping to my place on the leaderboard. This is the moment of truth. Automated machine learning got me 10,922nd out of 13,728. So this is both good and bad. One, it's not a bad prediction. I ran it for like 11 minutes and I just submitted it and it does a pretty good job. It was, it predicted, and let me just tell you what that number means here. It predicted that test data set accurately 76% of the time. Okay, not great, but not bad, right? And yeah, I was pretty happy with this. And the what was the point I was trying to make here? I think that this is just one of these things, though, that also is also reassuring to me, because there are also 10,000 people above me on this. So that means that even as good as automated machine learning is, it is not going to replace traditional machine learning methods and techniques of manually massaging and tweaking and tuning the data. Okay, where this is really useful, and this is kind of the last part of what I'm going to talk about here. These are just some of the options that are available. And I was thinking about doing a second one if I had time, but I didn't end up having time. But so there's limitations, right? And that's one of the things to point out here. It is really cool though, because it only took me 11 minutes and I got a reasonably good model that I can use, and I can send in new data and make predictions on it. Okay, it only works for the 3 types. You still require a little bit of knowledge of Python. Oh, that's a good question. Somebody asked, just curious, any ballpark estimate for how much the test run I just did cost on Azure? So I've been playing around with this stuff for the last week, let's say, and I've trained about, like, I would say around 40 some models with, no, let's say, well, I guess I could take a look at how many I've actually trained here. I've trained a bunch of them. I've only spent $30 in Azure doing all the training prep that I needed for this. I would have to guess it's somewhere around 50 cents to $1 to train that model, maybe less than that even. Most of that cost is because I deployed it into the cloud and it's running right now. And it's fast. It is relatively fast. Like if you've ever tried to train a model, this is a pretty fast process. It finds a good model pretty quickly. But it's still got those same limitations, only works in some cases. But where I see it really being of value and where I've really liked it is when you need to get results quickly, it does that. We train the model right here, right now. So if you go over to, I think it's actually probably done at this point, if I had to guess. Let's just check out what's going on here. I'll just go to the experiments, the classroom experiment that we set up here. Oh, it's still running. So it takes a while to process, but it should be done, the next 10 or 11 minutes, I would expect. It's also really good for pre-screening models. So one of the cool things about this is that if I go into one of my more successful experiments, like let's say the Titanic one that I predicted earlier, and I click into this Dreamy Dolphin, which was the run that I actually deployed, it used the standard scale wrapper. And hey, there's my favorite extreme random trees. This doesn't mean though that like again, no need to know all this terminology, but the idea is now when I go in and want to tweak the model, I might instead use extreme random trees instead of one of the other, plethora of algorithms out there. It kind of narrows down my search. Okay. It also helps identify features that you might need for more tuning. And what I mean by that is that most of the models that you train have some amount of explainability that you can build into them. So there's explanations you can produce. Some of them don't have explanations attached to them, but in some cases, and I thought I had one here, you can go in, let's say Dreamy Dolphin, and I thought it had explainability here. I'm just trying to see. I don't think this one does, but you can go in and see which features are the most important. And there's a nice little graph that you can look at that sort of shows you which features had the biggest impact on the prediction. And lastly, it also helps identify when more data is required, because if you try this thing for like a day or 2 days or 3 days, and with all the different And with all the different models in the world, and it still is predicting like 80% accuracy, might be a good time to go get more data. But the idea is that what this is doing is that it's helping you speed up your model development process. Instead of having to build the whole algorithm yourself off the hop, you can try out a couple algorithms, see how good they work, see if they deploy well, see if they predict well, and then maybe then go get more data, go play with the data a bit more, featureize it a little bit more, tweak it a bit more, pick a better algorithm, and it might work better, okay? Before you go and start writing code, okay? And somebody just asked here, how can we do this with the free version? I'm not sure about the question. Could you just make it a bit, just clarify a little bit more? I have one last recap question, and then we'll just go. Then I think we're pretty much out of time. We're almost done here. I'm just gonna open up my Zoom here. Meeting controls. What did I do with those? Okay, last question is, I think, here we go. This is not the right recap, but you'll see the recap that I sent. So which of the following is not an option available to automated machine learning? I see a couple of questions. We'll address them at the end here, just so that we can wrap this stuff up. Okay. All right, using neural network algorithm. Sorry about the slides here. I thought I had put this one in. So, okay, do 5 seconds, 5, 4, 3, 2, 1. End the poll. Just going to share the results. That I threw that one in as a trick, that neural network algorithm there. That's the deep learning. So remember when it said classification, if you remember when we were starting to set up the automated machine learning, it talked about deep learning. That's where it's going to use the neural network. So sorry about that. That was my, trying to trick everybody there. But the training and clustering model is also not available. So that's the totally correct answer. My neural network was a little bit of a trick. Hopefully, though, those of you who said you were at the top level expertise, you would have caught that one. Okay. So just to kind of quickly recap everything, we talked about our introduction to machine learning. You made it through regression and classification, so well done. We talked about cloud computing a little bit, and we talked about Azure Machine Learning and how it makes things a lot easier, specifically the automated machine learning features. Okay. So at this point, I'm just going to address a couple of questions in the chat and then just open it up for anybody else here. So how much is the free version? The free version is free right now. You get $200 as a credit if you sign up, and you can play around. I think it's $200 for 30 days. Again, if you want, try SageMaker, try Vertex AI, the Google and the Amazon and the Google product, because I think they give you a bit more credit, and they do basically the same features. But it's $200 for 30 days, and then there's a bunch of free services available. Azure Machine Learning isn't that expensive. Keith's just saying, what learning path do you suggest for a granular level of understanding? That's a very good comment, Keith, that sometimes there's some, pre-built libraries. This information won't necessarily get you the job, but it can help you make your life a lot easier when you're actually doing machine learning. But if you want to just message me, Keith, after the fact, maybe we can just, I can talk about some learning paths, okay? I have somebody saying, can automated machine learning perform hyperparameter tuning? It actually does perform hyperparameter tuning when it's doing the automated machine learning. And it actually tracks the hyperparameters. You can actually look at the logs of the data if you dig into it, and you can find the hyperparameters. By the way, hyperparameters, those are the things that you tweak in the algorithm to make things more accurate. And so it does. But the nice thing is that this is actually another bonus of automated machine learning, is that because it tracks the hyperparameters, you can then say, well, what hyperparameters made my model more or less accurate, and then have that as a starting point for when you do hyperparameter tuning as a data scientist or machine learning engineer. And then, do I have any models deployed in production, and can you give the use case overview? I have actually 3 models on Azure Machine Learning deployed into production right now. I have one that predicts Titanic data. one that predicts housing data, and one that does some other housing prediction. The test function wasn't working good, so I kept trying to deploy it again. But yeah, basically, if I go into here, it's like I showed you guys. If you go to test, I can read data in, take some of that data from the Titanic passengers, read it in to, I'm just doing this for ease, by the way, everybody, because I don't want to have to enter it all in manually. And it'll predict, this passenger 893, passenger class 3, the name's Miss James Wilkes. She did survive the Titanic. She didn't survive on the Titanic, unfortunately. Okay, does that make sense? Any other questions? Also, by the way, I really like DataCamp for learning some of this stuff on the more granular information. It teaches you a lot of stuff that's really practical and really applied. And oh man, that's a loaded question right there, Jeremy. When can you expect a decrease in your gas bill? We are trying to expand our data infrastructure and look at this stuff, but I can't make any promises, unfortunately.
Yeah, aren't you guys hiring over there?
We are. That's a good point. Yes, that's the last slide on my presentation. Thank you. So if you want to come work with me and Scott in the group here, we are hiring right now. We're hiring for a data scientist. So if you are interested and you have machine learning background, I highly encourage you to come out and yeah, see if you'd enjoy working with us here at Sask Energy. So yeah, we are a new team. Sorry, I'll just say a few more things. We're a new team, so we we're just kind of getting started. Analytics has really been growing from the ground up at Sask Energy, so there isn't a lot of legacy old code you have to worry about. We are working on some exciting projects, working on that meter data. Jeremy, decreasing your gas bill, maybe you can help out. And opportunities for professional development. We have lots of opportunities. We've got a very supportive structure that really helps foster a professional development environment, and we were really trying to help people grow in their profession. So any entry-level positions? Not at the moment, but I will say check back, and if there is one, we'll probably want to be you can always keep in touch with me or add me on LinkedIn, and if you see one go up, there will very likely be a more entry-level one in the future. It's just that we are starting from the ground up, so we do need a little bit more expertise just to kind of get our feet beneath us. And a machine learning specialist would be, if you've got all of the skills, you're the full package. I see there's a question about that. That's an excellent place to start. One thing is, because we are very new, we have to prove our value. So as much as the technical skills are important, we also highly value the people skills and the ability to work with stakeholders and the communication skills. Any other questions?
I'll say if there's Ryan is an active member of our Slack channel, so if you want to get a hold of him, you can join our Slack channel. You can email me at kevin.hayes@dataforgood.ca, and I'll add you to that. Or he's pretty responsive on the LinkedIn. Regan. Oh, Regan's an OG of Data for Good in Regina. We'll sneak one more question in, Regan.
Thanks, Kevin. Thanks for the presentation, Ryan. So one thing I'm wondering about is in the data pipeline, one of the big things is like in the supervised learning is you need that labeled data set, and sometimes the labeled data set is the hard part of it, is gathering the labels for it. Does Azure have any sort of like service for that, like whether it be like crowdsourcing or expert annotation or anything like that? Like if you need a data set labeled, do they have anything?
I'm not super familiar with that, but I do think they have something. I've not played around with it a lot, but there is sort of a data labeling service that is like baked into it. But that's more for like image classification and object detection. That's a really interesting idea. I don't know, like where you sort of, like crowdsource labeling projects where you attach labels to things. The most I know is this one. I haven't actually played around with it a lot because I just haven't had a chance to yet. But it can work with that image classification or object detection. And then you can also sort of like, you know, as my understanding, my limited understanding of this is that you can get, you know, your people in your team or whoever's doing some of the labeling for you to kind of contribute to this within the Azure Machine Learning workspace. You can give them access to it and they can kind of apply those labels for you. So I don't think it's not quite what you're looking for, if I'm understanding it correctly, but yeah, that's about all I know of.
Okay, yeah, thanks.
Cool. Well, thanks everybody for coming out, and well, everyone stuck around to the end. A very engaging presentation. Good job there, Mr. Tessier. We will thanks for coming out to Data for Good tonight. Last Tuesday of every month we are live. We'll be posting this to our YouTube page as well, so you can check out all the links. And I think Ryan's going to give us a slide, so we'll post that to our SlideShare account too, so you can find all the resources that he was talking about. Otherwise, thanks for coming out, everybody, and we'll see you next time.
Thanks, everyone. Have a great night.